Alright, in this video we want to look at the difference between displacement and distance. And so on here I have a little number line drawn, and we're going to kind of plot some things out on here hopefully in a little bit. So if we look at, we write down distance, and we also have displacement. For the symbol for distance, we usually use just D. And displacement, a lot of times I just use D also, but technically it should have like a D with a vector over it, like this. But sometimes they use S. And I don't use that very often, but they will in college sometimes, so you always might want to remember that. And sometimes we just do X, because we're going to be somewhere on the number line, a certain displacement on the number line. So distance here is what we call a scalar quantity, just a magnitude. Displacement is a vector quantity, which means it's going to be a distance with a direction. So a scalar quantity with a direction also. So these units up here could be like meters, and then we have, in physics we use what we call the MKS system, meters, kilograms, seconds. So everything needs to be converted in those units. So we're going to be in meters here. And if I had something like 30 meters, then that would be a scalar quantity. We'd call that a distance. But if I said 30 meters west, that would be a displacement vector because it gives you a magnitude as well as a direction. But what we've borrowed from math is mathematical symbols that can also mean a direction. We got to kind of get rid of our old ideas of what plus minus means and just think of it as a direction. So if I said 30 meters, or I said plus 30 meters or minus 30 meters, minus 30 meters just means we'd be going 30 meters to the left. So minus and plus are just going to be our directions from our from however far our position was that we started. So if we want to figure out how displacement, it would look like this. We're going to have a displacement vector. Let's do this. A displacement vector will be your final position minus your starting position. And so I could be anywhere. I could start anywhere on the number line here. I could start here. This is my xi, we'll say. And here is my xf. And so if I figure out my displacement vector, my final velocity is at position 1. That's at plus 1. And my initial velocity, 1, 2, 3, 4, 1, 2, 3, 4, 5, sorry. You subtract your initial position, and my initial position is plus 5. So 1 minus 5 is minus 4 meters. There would be my displacement vector. All this means is that I'm going 4 meters to the left. That's all it means. I started here, and I went 4 meters to the left. 1, 2, 3, 4 meters to the left. So the negative doesn't mean craziness. It just means that it's just the direction you're going. I'm going 4 meters in the direction of the left. And you'll notice that in both positions were positive numbers. So I'm on the positive side of the position line, but my displacement still is negative because I'm going in the negative direction. Let's do another one. Let's say I'm starting here and I'm ending here. So the displacement vector would equal my final position, 1, 2, 3, plus 3, minus the starting position, which would be 1, 2, 3, negative 3. So I'll have negative 3. And 3 minus a minus 3 is 3 plus 3, which equals a positive 6 meters. And so this means that I apparently went 6 meters to the right. So I started here and I went 1, 2, 3, 4, 5, 6 meters to the right. And so I have a displacement vector of plus 6 meters. So even though I started with an initial position of negative 3, my displacement vector is a positive value because I'm going towards the right. So that's displacement. Distance, of course, would just be the absolute value of any of these. So if I just said I went 4 meters, that's a distance. If I said I went 6 meters, that's a distance. But if I put negative on the front of it, that means I have a displacement. I went 4 meters to the left. Or I put a positive in front of it, that means I went 6 meters to the right, and those become then displacements. Distance is just the distance, the absolute value of the displacement, how far you traveled. So I could travel, a big long distance like this. But if I want to find my actual displacement, I'm going to go from where I started to where I ended, and that will be my displacement vector. Even though I traveled a long distance, my displacement vector will be my starting position to my final position. So I hope that makes sense on displacement versus distance.